Hello and welcome to another episode of this tutorial. My name is Rohit Das and today we are going to discuss about multidimensional arrays. In an earlier video, I had discussed about what arrays are, and in the previous video, I had discussed about pointers, how we can use them to access memory locations directly, how we can use pointers to access array elements, and various notations that we can use to access those elements as well as the addresses. And we are going to use that knowledge here today in learning multidimensional arrays, right? We'll be using the normal bracket notation as well as the pointer notations that we had used by simply incrementing or decrementing the pointer addresses, right? So let's get started. So for now, at the beginning, I'm going to teach about two-dimensional arrays. I'm going to show pictorially how two-dimensional arrays are actually conceptualized and how they're actually stored, right? So they're very different actually. The actual physical implementation and how we conceptualize it, they're very different. Basically, conceptualization is very important if you want to be a successful or at least a mediocre programmer as well, because without conceptualization you won't be able to navigate your own data structures, right? Nevertheless of how it is stored in the physical memory. Okay, alright, so this is how a two-dimensional array is declared. Earlier in one-dimensional array we had only one pair of third brackets and then we had a value inside it. Now we have another pair of third brackets and we have another value inside it, right? Just like that. Alright, so what this is creating, actually this is creating a two-dimensional array, 5 cross 5 array, actually 5 rows and 5 columns. How it is, it's actually conceptual. I'll show it in a moment, right? So this is how the array is initialized, right? And to go through all of the elements we have to run two arrays, right? So if it is an n-dimensional array, we have to run n loops to go through all the elements, to be able to go through the elements, right? And now I'm going to show you how we conceptualize a multi-dimensional array or two-dimensional array for now. Alright, so earlier we had talked about one-dimensional arrays. So one-dimensional arrays basically look like this. So this is a one-dimensional array because it has only the length dimension, and the actual memory implementation was it started storing it from a certain physical address and contiguous memory locations were occupied, right? In two-dimensional arrays things will be a bit different, right? So let's write it 2D array. Alright, so let's take an integer array as always, int arr 5, just like I had shown. So this is how we initialize a two-dimensional array of number of rows 5 and number of columns 5, right? So how do we conceptualize this? We can imagine having a single table having 5 columns and 5 rows. 1 2 3 4 5 1 2 3 4 5, right? Alright, so this is how we conceptualize a multi-dimensional array as being a table or a matrix, if you like. If you have learned about matrices in maths, in linear algebra, so that's the same thing. It's the same thing over here. It's having two dimensions. One is the number of rows and the other is the number of columns, right? So in two-dimensional array, the first number, it represents the number of rows, as we like to call it, and the second one represents the number of columns, right? I'll just simply write cols. Okay, so the first number represents the number of rows and the second number represents the number of columns. This concept is only applicable to 2D arrays, right? Why? Because as soon as the dimensions increase, there won't be any number of rows, columns, etc. All right, there will only be dimensions and at which level we are. All right, so we can imagine this to be the first 0th level and this to be the first level, because the indexing starts from 0 in arrays, right? So this is how the concept is taken, and indexing is done just like that, just like in a normal linear array. We just remove these. Okay, so the first row will be 0, the second row will be 1, third row will be 2, fourth row will be 3, and fifth row will be 4. Similarly, the columns will be numbered in the same way. It is not necessary that the number of rows has to be equal to number of columns. We can change it as well. I'm just showing a 5 cross 5 so that it can be understood better. Alright, so this is how rows and columns are numbered. And now suppose we want to access a location, let's say over here, right? So we want to access this location over here. Okay, now how are we going to access this location? In normal linear array, if we had an element, let's say index this 0, 1, 2, 3, 4, right? Now if you have an element over here, how do we access it? Simply write ARR 3, right? We simply write the index and we get the value stored at that index, right? It's a similar case with 2D arrays as well, except that we have to use an extra indexing, that is the column indexing we have to use. So first we are going to index the row, right? Arrays are accessed in row measure, that is the row is first accessed and followed by the column, right? So the which row number is it? It's 1, so you can write 1 over here. And which column? 3, so we are going to write 3 over here. So ARR13 is going to give us 10, which is stored over here, right? Similarly, we can get to any other value over, let's say over here, right? So let's see if you can guess this. You can pause the video and see if your guess is right in a moment. Alright, so this element will be accessed as being ARR 3 and 1. So this is going to give us 15. Alright, so this is how we can access the elements in our 2D array. And as you can see, since there are two indexes over here, there's this index and then this index, right? So for changing this index we need one loop, and for changing this index we need another loop. So that's why I said that if an array has n dimensions, we will be requiring n loops, right? And all of them will be nested loops, as we are going to see while programming. We are going to insert elements into the array, print the elements, and maybe manipulate with them a bit, right? Okay, so now we are going to move on to the programming part, where I'm going to use the bracket notation, and later I'm going to show how we can access these elements using pointer notations as well. Alright, so now we are going to do a little bit of programming using 2D arrays. So as usual, I'm going to declare a 2D array of size 5 cross 5, because like in matrices, we first mention the number of rows followed by the number of columns and a cross in between. So it's an array 5 cross 5. And now I'm going to show you how to access the elements. So first I'm going to take input, user input of course, and then I'm going to change them, right? Let's not make it 5 5, let's make it 2 2, because 5 5 I have to enter 25 elements, right? So that'll be kind of tiresome, or maybe not. Let's see, I'll show you a trick. Yeah, that'll be better. I'll show you a trick. Enter 25 elements. We make it %d 5 into 5, right? And then we have a for int I equal to 0 g. Alright. So I'm not going to skip the initialization part over here. I less than 5 plus this. For in j equal to 0, j less than 5, j plus plus. Alright. So what's happening over here is that I'm using a nested loop, right? One loop running inside another. Okay. Now, when I had explained about iterations, loops, I had also spoken about nested loops and how they work. Basically, I had told that the total number of iterations will be equal to the number of times the inner loop runs multiplied by the number of times the outer loop runs. Now, if there are n number of nested loops, simply start from the innermost loop. You count how many times it runs, multiply it with the outer, just the outer one, right? And keep multiplying unless you reach the outermost loop, and you'll get the number of iterations. So over here, what's happening is that j will iterate from 0 to 4, right? That's 5 times, multiplied by I will iterate from 0 to 4, that's 5 times. So 5 into 5, that will give us 25. Alright. So we have 25 locations in ARR, and so we are going to need to iterate 25 times, right? And also this is going to help us access the elements in row major order, right? So let's continue. So we are going to take an integer as input, and as usual and ARR I j. Okay, so I is controlling the rows and j is controlling the columns, right? So when we are at row 0, we are going to go at column 1, 0, column 1 up to column 4, and then when we are going to move to row 1, we are going from column 0 to column 4, and we shall continue, right? So if you can observe it, if you can imagine, conceptualize it, you can see that the columns are continuously changing, right? From 0 to 4, again coming back from 0 and then to 4, whereas the rows are not changing as much, right? So for every iteration of the row, for every increase of 1, the column will be completing its 5 iterations, right? And that's going to give us 25 iterations. Okay, so this is a simple input, right? And then we are going to do the same thing. Instead of writing it again, let's simply copy it down. Alright. Well, copy paste is a miracle, isn't it? Alright, so let's change this over here. So space, and let's put a new line, because at the end of, after printing each row, we are going to go to the next line, otherwise it will look bad. Alright, so this is how we take user input in a 2D array, and this is how we print. The loops are simply the same, except these commands just vary. Here it's scanf and here it's printf, and after every iteration, after every 5 iterations, that is after covering each row, we are going to print a new line so that we can go to the next line and it doesn't look shabby. Alright, so instead of manually entering 25 numbers, what I'm going to do is that let me show you a trick. Okay, let's see. Let's close this and let's open another new program on C. Alright, so what I'm going to do is I'm going to write a simple loop, right? That's going to print from 0 to 25. Int I equal to 1, or I equal to 1, I less than 4, plus printf %d maybe let's put some space. Right, so we're going to close this program. Let's compile it on this side. No errors. And now what we're going to do is that we are going to store the output of this program in a file, right? Output.txt. Now let's see what's there. Right, so as you can see over here, what has happened is that basically when we run a.out, it simply runs the latest compiled program, okay, and this over here is a symbol, it's a syntax for bash. Basically what it does is that it takes the output of this program, simply passes it and stores in this file, okay, and we can overwrite the file anytime we want, okay. Now there's a percentage that's coming over here, so let's correct that. These are some programming practices and tricks that you can use in your daily college lives to make things easier, because why not? Alright, so instead of putting a space, let's put new line. That'll be better. That'll remove the percent as well. Save that, compile that, and do that again. So as you can see over here, our previous output has been overwritten, so that's a good thing, because we don't have to create a new file and then do it again. And it has been, now it has 1 to 25 digits, okay. Now if I want to enter random digits, that's entirely different. That's entirely up to you if you want to work so much. I'm just doing it just to show how it works, how a two-dimensional array works, right? So let's open our program again. So this is our actual program. Let's clear the screen. We just ran it. Now, just as for output we use this symbol, for input we are going to use this symbol, right? Okay, so we just entered 25 elements, but since we passed the input from this output.txt, it simply takes the text from the file and passes it as input, okay. And since enter is a delimiter, it automatically takes all the 25 elements, and this is how the array is printed, right? So this is the first row, this is the second row, and this is the first column, second column, and so on, okay. You can adjust the spaces in between using tabs and whatnot, okay. I'm just showing over here how a 2D array looks like, basically. So this is how a 2D array input is taken, right, and this is how a 2D array is printed, okay. Alright, so now I'm going to try and print the addresses of the locations to show you how the locations also change. Okay, so there's error, comma, and error ij. Okay, because we are actually using pointers to, or not pointers, a single pointer to access all of the memory locations linearly, contiguously actually. So we should get all of the addresses as well, okay, and they should look contiguous. Alright, okay, let's compile that again and let's pass our initial input. Okay, that just doesn't look good at all. Okay, let's put a new line over here to make things a bit more legible. Alright, so I think that's much better because we have new lines at the end of each row, okay. So as you can see over here, for each row these values have changed by 4 since each integer is of 4 bytes, and here are the values. And as soon as the rows change, this changes to C, okay. Now ideally this should have been C0, C4, C8, right, CC, D0, right, but the addresses aren't like that, okay. What's happening is that this is actually stored in the memory linearly, alright. So as you can see over here, this ends in C0 and the next one starts with C4. Okay, so a 2D array is nothing but a 1D array in actual memory. Okay, I'm going to show you how it actually is stored, how 2D arrays are actually stored, or how multidimensional arrays are actually stored. They are actually stored linearly. There is no concept of multi-dimensions in the physical memory, right? The physical memory locations are all one after the other. They don't have two dimensions. It's not a table inside the memory. Okay, it's just a list rather. So basically you can see over here it has already created a list of elements. You can see how the elements increase, and since it's in hexadecimal, after B comes C, D, E, F, and then this changes to 2. Okay, so basically these are all linear elements. Okay, there is no concept of multidimensionality in physical memory implementation. Okay, and this is what I wanted to show you, how actually multidimensional arrays are stored linearly in the actual memory. Okay, and now I'm going to show you diagrammatically how that happens. So just now we had seen how multidimensional arrays are actually stored linearly in the physical memory. So let's see how that happens. Let's take our initial array that we are working with. Oops. So this was our initial array, right? Now what compiler does is that it actually creates a 1D array of size 5, and the initial location is of course pointed by our pointer ARR. And now what happens, each of these memory locations can be accessed like this. ARR, let me draw it a bit lower. ARR 0, ARR 1, right? So this is how we can access each of the memory locations. Alright, and now what happens is that each of these memory locations now point to a 1-dimensional array of size 5. Okay, seems logical. Right, so let's zoom it out. So what happens is that initially this array over here is actually an array of pointers. Sorry, PTRS for sure. So this is an array of pointers, and each of the pointers can be accessed by using this bracket notation ARR 0, 1, 2, 3, 4, and each of those pointers point to separate arrays of their own. Okay, and that's how we get a two-dimensional array, right? So here you can see a basic table form is done. This one is a 4. Okay, right, so a basic table has been formed, although they aren't connected, but we can access each of them using ARR 0, 1, 2, 3, 4. So that's why I was saying that the first index actually points to the row, right? And this is how actual locations are saved in the physical memory. Okay, and we can access each of them using ARR 0, 0, ARR 0, 1, right? So these actually become array pointers of their own, right? Because they're all individual pointers. And if we imagine the ARR 0 to be like simply ARR, how did we access linear arrays? ARR 0, ARR 1, right? So instead of ARR, we are getting ARR 0, so that becomes ARR 0, 0, 0, ARR 0, 1. Okay, and that's this is how the actual implementation is done in the physical memory. And as we know, each of the linear memory locations are allocated contiguous memory locations in the physical memory, right? So the first array gets like maybe the first 5 locations, 1 2 3 4 5, and then the next array gets the next 5 locations, and then the next array gets the next 5 locations, right? And this is how the arrays are actually saved linearly. Okay, the pointers store the locations, like at first the array of pointer gets allocated a memory, right? 5 memory locations, and then they point to each of these 5 memory locations. Like this one points to here, this one will point to the next 5, okay, and then the next will point to the next 5, right, and so on. So this is how the 2D memory, 2D arrays are actually implemented in the memory, right? Hope you understand that. And now we are going to use our pointer notations to actually access them. Okay, let me show you how we can use the pointer notations. So earlier we had known that ARR is a pointer, right? So if you want to access the indexes, how did we access it? So ARR gave us the first value, ARR plus 1 gave us the second value, and so on, right? So ARR 1 is actually this one. So let's work with ARR 1. Okay, so let's go over here. So ARR plus 1, what is this actually? This is actually the address of location ARR 1. Okay, if we use the bracket notation, it actually gives us the address of ARR 1, right? But since it is an array of pointers, we are only going to get the addresses. We don't have any values as such, right? The values are actually other addresses, the other location. Okay, so let's see what happens over here. So we have the memory location over here, and if we add something more with it, let's say 2, and then try to access the value over there, this is equivalent to ARR 1 2. Okay, so let's understand what's happening over here. Initially we had ARR, that's the actual pointer to the 2D array, and then when we do ARR plus 1, we are actually accessing ARR 1, like over here. Okay, and then we are adding 2 to it. Okay, so we are basically adding 2 into 4, 8 bytes to it. So what it's going to do is that it's first going to go to the location which is stored in ARR 0, and then it's going to increment that location by 2 steps, by 2 elements, and then it's going to access that element basically. Okay, so I think if I show this in the code, it'll be much easier to understand. So let's get back to the code. Alright, so let's edit our code a bit. Instead of accessing our elements using bracket notations, we are going to now use pointer notations over here. Alright, let's change the layout a bit. Oops, sorry about that. Alright, I think this is better because it uses the length. Alright, let's change the layout over here as well. Okay. So I'm going to make some changes over here. Okay, so let's erase this part. Since the first thing that we're going to do is access the value, so ARR plus I, that's going to give us the row. So some brackets. Right, this is going to give us the row, and then we'll require the column. Okay, so hopefully this is going to let us access the elements. Let's just access the elements only for now, because even I'm not quite sure about the output. Okay, let's see. Okay, so we're getting some warnings. So here expects the argument of type int. Format percent expects argument type int, but argument 2 has type int star. Okay, so probably we need another star over here. Why? I'll explain in a bit. Yes, that corrected it. Right, so actually we need another star over here. Okay, so what's actually happening over here, let me explain it. So earlier we had seen that if we do ARR plus I, let's say if I is 0, okay, or 1 for that matter, let's say I is 1, so ARR, it simply points to the first location in the memory. Okay, and now if we do ARR plus I, what will happen is that it will we are taking I as 1, so what is going to happen is that it's going to give us the address of ARRI, right? So ARRI, it's a pointer. Okay, so ARR1, it's going to give us the address which is stored in it. Okay, and we need the actual address which is stored at that address. Okay, so let me go back to the pictorial representation again. Alright, so let's try and understand how I use the pointer notation. Alright, so we are going to take a very small array. Let's say we take ARR equal to maybe 3 elements. That will make it much easier to handle. Alright, so how do we access these memory locations? Okay, since this is an array of pointers, mind it, initially it's an array of pointers. Okay, so 2D array is nothing but first a 1D array of pointers is created, and then those pointers then point to individual array of elements. Alright, so now how do we access ARR 0? Either by this or using this notation, right? We have studied earlier in pointers and arrays both that we can use these notations to access ARR 0. Alright, so similarly I can access ARR 1 simply by changing this to 1. Right, now let me draw the actual 2D representation of what's happening. So each of them point to separate arrays. Let's say they are of size 3 as well. Alright, so I had already earlier seen that to access the value at ARR1, I have to use this notation over here, that is ARR plus 1 and then a star before that to access the value at ARR plus 1. Right, so this is equivalent to ARR 1. Now where is ARR 1? ARR 1 is actually pointing to this array over here, right? So we can write this as ARR plus 1 star. This becomes a new address, and now this is pointing to this array over here. Now suppose I want to access this memory location. What is this? This is the location at index 1. How do we access that? ARR 1 1, right? Now how do we access this part? This is ARR plus 1 star. Now how do we access this part? Simply put a bracket and increase it by 1. Because this is a pointer, we are incrementing the pointer, we are accessing the value at that pointer, at that address, right? ARR gives us an address, we are increasing that address by 1, and then we are accessing the value at that address, which is also an address, right? So in two-dimensional array, there is two sets of address accessing, right? So there are two sets of addressing. First, we have to get the address from the original array of pointers, which points to the corresponding 1D array, and then from there we can access the element. So first, this ARR plus 1, what it does is that it simply increases the address inside ARR by 1. This star helps us to access the value inside ARR plus 1, which is another address, and then we increase that address by 1, and then we access the value at ARR 1 1. So this is how we can use pointer notation to access elements inside the array. Alright, and this is similar to bracket notation. Mostly we use bracket notations because, as you can see, the pointer notations are clearly very confusing, but I'm simply telling this because this is worth knowing, right? You can use this knowledge to solve questions in various competitive exams and in SEM exams in universities, colleges, etc. Right? Okay. So I hope this part is clear, how we use pointers. The last bit that I'm going to explain, I won't show the coding of it because you can do it yourself and check it out. We have seen that when we are making an array, we are making uniform lengths, right? Let's not make it 5 5. It's too cumbersome to work with it. Let's make it 2 2, right? So we are doing this. Okay, now what's happening is that ARR 0 is pointing to an array of size 2, and ARR 1 is also pointing to an array of size 2. Well, this is not the case. It doesn't have to be that each of these pointers have to have arrays of same size. Okay, like ARR 0 is pointing to an array of size 2, ARR 1 may point to an array of size 4 or 5 or whatever. It can change, right? It doesn't have to be uniform. So how do we make an array? How do we make a multidimensional array where the number of columns is not same in each row? Okay, so let me show that quickly. So basically what we are going to do is that we are going to declare an array of pointers, right? We are going to declare an array of pointers, and then what we are going to do is that ARR 0 is equal to int, sorry, let's make another two arrays. Let's say int BRR 2, this is a 1D array, and let's say int CRR 5, this is another array, right? So this is in tandem with what we have just learned, how two-dimensional arrays are actually stored in memory. First, an array of a 1D array of pointers are created, and then each of those pointers are separately allocated other 1D pointers, right? So I'm just exploiting that idea to create a two-dimensional array where each of the rows have different columns, right? So this is an array of pointers, of integer pointers, and these are my 1D normal 1D arrays. Okay, and now what I'm going to do is that ARR is my array of pointers, so ARR 0 is my first pointer. I'm going to make it point to BRR. Now BRR is what? BRR is over here. It will point to the first memory location of two array locations. So ARR 0 will look like this. It will point to this, right? And this location is marked by BRR, which is now going to be marked by ARR 0. And next what I'm going to do is that I'm going to mark it as ARR 1, mark it as CRR. Okay, now what ARR 1 will point to is that it will point to an array location having size 5, basically, because CRR was of size 5 over here, as we can see. So this is how we can make arrays where rows have different columns. And now how this is going to look like is that it's going to look a bit like this, right? There's 2, 3, 4, 5. So this is going to look like this, kind of crooked and corrugated, but this is the idea of 2D arrays, right? So this is all that we learned today about 2D arrays, how to access elements in 2D arrays, how they are actually stored in the memory, right, and how we conceptualize them. and how we can use them in our programming languages. Alright, so that's it for this video. Hope you guys enjoyed it. In the next video I'll probably start structs and unions, and if you liked it, leave a like, comment, share, and also give your feedback about how I can improve my videos. See you guys in the next episode.